Hello, and welcome to devlog index 7. Uh, this will be a code session where we will be developing compiler completely inside of the browser. Compiler for a language that was already implemented in uh, Rust. So here is the existing compiler, and here is example of the language, a very small example. So basically, this compiler is already done, but what we will be doing now is starting on writing the compiler for this language in this language. So for some context, there is a devlog in text format, chapters 0 through 7 through 6, because it's starting from index, where you can learn more about the creation of this language. Links will be in the description. So let's start with IDE setup. We will be using vscode.dev, an IDE completely inside of the browser. So basically you just go into vscode.dev and you have an IDE. After that, let's actually show how to do that. Then we will open a remote repository. You need to create a GitHub repository before that. So we'll open a repository, which I already created, and we'll open a branch. And yep, that's what you can see. We only have one file. Let's set up the extension. This language already has VS Code extension for some quality of life. Basically, how to install it, it's as simple as always with VS Code. You just search for your extension. Here it is, low language support. The language, by the way, is called low, which was standing for low level something, but currently it's just low without explanation. Yeah, let's just install this extension. It will prompt to install some additional extensions that it uses. And that's it. That's the IDE setup. It will install the actual extension and 2 experimental extensions for working with WebAssembly. Because this is all working completely inside the browser, we will be relying heavily on WebAssembly. Basically, yeah, let's see what is a WebAssembly. WebAssembly, a binary instruction format for a stack-based virtual machine. Is designed as a portable compilation target for programming languages, which is exactly what we are doing, and enables deployment on the web for client and server applications. Great. So basically, in simpler words, is just a binary format which works in most browsers, as you can see here. And not just inside of the browsers, there is also projects like Wasm-Time and Wasmer and many others which run WebAssembly on the server. So this will not be just for the browser. You will be able to just run normal applications with it. Yep, so that's a small overview of what we are targeting. That would be WebAssembly. Okay, so we have our extension set up. Let's Okay, so there's one more step to initialize the project. You do Ctrl+Shift+P for command palette, and then you type in low initialize project in current workspace, and that would create some files. And the technical issue, 1 second. Okay, we are back. So basically these extensions are a bit experimental, and there's some problems with files not showing up sometimes, but yeah, it's being worked on. Yeah, so this command basically creates the main file, the main source file. It also copies the actual compiler, which is itself a WebAssembly binary, and it also creates a lib folder which has basically a standard library and some other functionalities that we will use. This is just a quick way to initialize the project and kickstart whatever you're doing. Yep, so this binary is actually created by Rust, and it is also here in the repository, links in the description again. So basically how it's built, you just run cargo and compile the existing source, and that will just produce the binary. And let's see what it can do. So we create a new web shell. This is the functionality provided by this extension. A shell for VS Code. Let's zoom out a bit. A shell for VS Code web. Yeah, I will also link that. So basically what it creates is this terminal where we can run some commands inside of vscode.dev. It's not a full Linux terminal, but it has some commands that resemble it, and the low extension also contributes to this terminal with run command. So let's see what we can do. So let's run the compiler, run low wasm, here it is. And yeah, as you can see, it expects a file and some options. So let's provide a file, run low wasm main low, and as you can see, you have some output, and what it is actually main law compiled in WebAssembly. Of course, this is not very useful in this form, so let's actually pipe it into a different file. Let's call it main.wasm, and as you can see, it created another binary with the same format as the compiler, .wasm for WebAssembly, and basically we can just run it the same as we ran the compiler, and as you can see, we got the hello world. It is that simple. You just run this and you run your executable. So how this works behind the scenes, we are using WYSI. Let's see. So WYSI is a WebAssembly system interface. Is basically an interface for a group of standard APIs. Yeah, it doesn't really. It's basically a system interface. So what we use it for is for file system access for reading and writing to standard output and stuff like that. So yeah, let's see the source of the main program. Basically what we have here is the syntax similar to Rust-ish. We have this fun keyword for declaring functions. Simple stuff. We have includes as in C, but they are a bit smarter. They won't duplicate files, so you don't have to do like if, def and stuff like that. We also have some go-tos from the extension, so we can actually go to the files, and all files, there is no hidden stuff, so everything you see, so all includes will point to actual files. And we also have, so here we see the CLI helper, the standard library, some helpers for using WASI, like for opening files, reading files, writing to files and to standard output, which is what we are doing. And also some printing utilities we have here. So let's actually see what this does. So the main function calls the puts function, which prints the string, which actually calls the file puts function. Puts stands for put string, so file puts string, the file being the standard output, and that does some allocations for the string and passes it into print string, which accepts a string by the pointer here. And then we actually finally, we also allocate some stuff for number of bytes written, and we finally call the WASI function, WASI-fd-write, for writing into the file. And we pass the string to write, and we say that we want to write a single string, and we pass the number of bytes written into this memory location. And we ignore all the errors for now, because printing to the console, we don't want to handle any errors related to that. Yeah, so that's the simple overview what is created by the initialize command. So let's start with what is needed for the compiler. Let's see, compiler, Wikipedia. Let's see. Do we have diagram? Compiler steps, diagram, compiler phases. Yeah, that is kind of a lot. Yeah, let's just show what we have in the Rust version. So basically the compiler is pretty simple. It contains, let's see, ignore all the setup. So basically the compiler is somewhere here. Let's hide that. So what we do, we first parse the file, then we, no, there must be something else, yes. Yes, so first we lex the file, which is a responsibility of the lexer, that will turn the file into a token stream. which we will use inside of the parser, and the parser would turn the token stream into some form. Yeah, let's actually maybe draw it. Let's see. Shapes format, yeah. So basically, we first have our file. Let's zoom in. Yeah, like that. We first have our files, and we would pass it into the Lexer. Let's make that maybe another step. Like that. Yeah, so we pass a file into the Lexer. Lexer will produce the token stream, tokens, whatever. Then we would pass tokens into a parser. And that would create some kind of representation of the program. Let's just call it, let's actually call it as I call it in there. Let's see. Parsing files. Yeah, let's just call it some kind of program representation. Program info. And the final step, we will be just taking the program info and we will pass it into the binary writer, which would just assemble all the stuff that we have into the actual binary. And this final step will get us the .wasm file. That's the whole compiler. Just three steps. Kinda simple, but yeah, it will get involved in the parser step specifically, the biggest one. We don't have more steps here. We don't have the like abstract syntax tree or anything else. We don't have like optimizations here. We are trying to keep things very simple, so it will be easy to change and understand. So yeah, let's start with let's start with let's see. Okay, after thinking for a while where to start, let's actually start with our interface, what we will be actually running. So let's create a new file called low, standing for the name. Let's copy the boilerplate, or maybe, yeah, let's call it low. Okay, so the first thing that we need, we want to reproduce the existing compiler. So we want what? We want to parse some arguments. and then we want to read files and process that. So let's do exactly that. Currently there is no way to read arguments here, but we have a module for that inside of the examples. So here is the module for parsing the program arguments. Let's just copy that here. Simple as that. And let's see how to use it. We basically first need to call args load, which will load all the arguments, and then we could get the argc, which is the count of arguments from the struct returned from that, and then we can read all the arguments with args get and the index of the argument. Okay, so let's proceed with that. Let's create arguments like that and load. Let's make sure that it works. It doesn't because we are not including that. Okay, here's the arguments. Let's see. So if we have, yeah, let's see. So we want at least one argument. So if argument count is less than 1, then we probably want to exit the process with an error signal, and we also want to print some error message. We want to print it into error, standard error stream, and we do that with fputs. So that would be quasi fg standard error and a message here, and the message will be the same as here. So we will just print the usage. Yeah, you probably cannot see that, but that's not important. Yeah, so if there is more than one argument, then we would actually take the first argument. Let's get the file name as args get args.get first one, and here we get it, the file name, and let's just for now print the file name and exit file name file name. We also need to print new lines everywhere. Yeah, so let's run this. Let's first compile it. So run low wasm. Yeah, here's the weird part. We want to compile it into low.wasm, but that would overwrite our existing compiler. So let's actually write it into low2.wasm, and that compiles, and let's run it. And yeah, that's not expected. Yeah, probably some bug. Let me fix it real quick. Okay, so looks like there's no bugs. Basically I forgot a thing. So the first argument would be the program name, which over here would be run, because we are running WebAssembly executables through another program, but that's not important now. So basically we need to check for at least two arguments. First one will be the program name, and the second one will be the file name. So let's actually get the second argument, and let's recompile and run that. Yeah, and now it works. So we expected the usage here, because we didn't provide an argument. So now let's try to provide some argument. Let's say 1, 2, 3. And yeah, as expected, we actually got it as the file name 1, 2, 3. Yeah, so that's the setup here. Now let's actually try to read the file. So let's create just some test file, test.txt. Let's put some test data here, and yeah, let's try to read it. We actually have the another module for that, which we copy from here. We'll also link everything in the description. So let's create the module here, and what we are interested here is fs read file. So let's try to read the file via the file name, which is probably more of a file path. Okay, let data equals read file. I also want to import that, include it actually, libfs. Cool. So that would read the file and just print to standard error if there was an error opening the file. And yeah, let's see what we read here. Yeah, let's just print it, puts data. Let's probably also wrap it into O. File file data. Let's see. Yeah, so we have a reference to a vector here, which is actually, yeah, let's comment it out for now. Let's see what it returns. It returns a reference to a string, and strings are actually, where is the code assist? Yeah, so strings are basically vectors. Let's see, yep, type string, yep, so the type string is the vec of u8, and vec of u8 is just a vector, and that is the a vector that you have in the normal languages, like also known as dynamic array, growable array, array list, or whatever. So there's no special string type, so yes, so we cannot print it like that, but we can print it with the print string function. let's see, or maybe yes, with a print string, and then we can let's see what we can do. Standard library string from string, or string from string. We probably want that signature. Yeah, so let's go on and use that here, and we can actually do puts now. Cool, so that actually converted it to the type we expect, and let's see how it works. We recompile and run it with test.txt, and we actually read the file. Cool. So yeah, so that was already 30 minutes. Let's see what we can do here in the first session. Yeah, so we read the file. Now we probably want to read lines, like read line by line, or actually character by character, but I think I'm gonna leave it for now. Yeah, that's it for the first devlog in video format. I hope it is not very cringe. Yeah, we'll see how it goes. Yeah, that's it for now. Bye.